Okay, alright, welcome back guys to module 2 of the Direct Access Music Production Workshop. Okay, so early on module 1 we talked about Music Production 101. Now we're going into module 2 where I'm going to be explaining a little bit about microphones and the microphone operating principles, okay? Right, microphones are going to be your best friends, are going to be the tools that you're going to be encountering and using all throughout your production process lah. Okay, so microphone basics. A microphone is an acoustic to electric transducer or sensor, right, that converts sound into an electrical signal. So transducer here means any kind of device which converts energy from one form to another lah, right? So this takes you back towards your science lessons, okay? Right, the principle of the conservation of energy. Energy cannot be destroyed or created. It is only transformed from one form to another, okay? Right, so in this case, right, a microphone is a transducer, right? It's a device which converts, right, the sound waves, which is a form of sound pressure, which is a form of a kinetic energy, into an electrical signal, right? So that's electrical energy. So there are the three most common varieties of microphones. Number one is called the condenser, or in bracket, the older name we refer to it as capacitor microphones. Number two, the dynamic microphone. And number three, the piezo, right? Some people pronounce it as piezo, some people pronounce it as piezo, okay? Now, in a condenser microphone, which is also known as a capacitor, the diaphragm acts as one plate of a capacitor, okay? So, anybody knows back in your kemahiran hidup what the capacitor is? Capacitor is a component that stores a charge. That stores an electrical, it can actually store electrical charge lah, capacitor, okay? So, the diaphragm, right, the one that responds to the sound waves, it's one plate of a capacitor, and the sound vibrations, right, it produces change in the distance between the two capacitor plates. So this diagram will show you a little bit. You have the sound waves coming in from the left. It strikes the diaphragm on the front, which is the front plate, and then the back plate, sometimes it's fixed, and when the sound wave strikes the diaphragm, it vibrates, and the capacitance, when the distance between the front plate and the back plate changes, it creates a capacitance, right? And that capacitance is outputs as an electrical signal. Now, you take note that some of them have a battery, and I'll explain why. Now, generally, condensers are more sensitive, okay? And they produce a more accurate audio signal. Very commonly, we're going to use condensers a lot in studio recording applications. Now, condensers, they require a power source. You need the power. You need to power the capacitor. There is a current that's running through the circuitry, and not current actually, a voltage, right? Yeah, electrical engineers will correct me, okay? Right. Oh, there's a voltage. So this is provided from the microphone inputs, the way that, you know, people have designed the microphone inputs, right? The XLR pin channels. So as phantom power is provided through the mic inputs as phantom power, or from sometimes a small battery, okay? So there are some microphones, condenser microphones, that can be battery powered lah, alright? Now some tube models, okay, will require, okay, because they have a much more higher current, right, they need a higher voltage, will require an external power supply, alright? So the phantom power that's coming from your preamp is not enough, they need a dedicated power supply on their own. Now, electret, okay, so sometimes you will see the word electret, some condensers. What they have is they have a permanently polarized backplate. So this means that electrets usually, like, they either, some of them I know do run on battery, and electrets basically don't really need to have the power. They don't need the phantom power, okay? But generally, electrets are usually the cheaper, you know, not so good quality ones lah. They are usually of a lesser quality, okay? So be mindful when you notice electret condenser, usually means a cheaper one. So this is a photo of the iconic and the Neumann U87, which is probably the most famous vocal microphone, condenser microphone lah, in the world lah. Do we have one here? We do have, right? Yeah, I remember. Right, so now dynamic microphones. On the other hand, dynamic microphones, they work via the principle of electromagnetic induction. Again, this takes you back to your science lessons, right, of the day, okay? So what does the electromagnetic induction mean? Now, there are three main types of dynamic microphones. You have the moving coil, you have the ribbon, and you have the carbon microphones, okay? So these are classified as dynamics. So a moving coil, right, contains literally a coil. It's like a coil. It looks like a spring attached to the diaphragm. So it's positioned in the magnetic field of the permanent magnet. You have the coil, right, and then you have a magnet in the middle. So when sound waves hit the diaphragm, because the diaphragm is attached to the coil moves, and then this in turn generates a small current, right? So the current, which varies, okay, according to the sound that it hears, lah. So these are again, right, images of very, very iconic ones. Here you have the Shure SM57, and there it's the Beta 52, okay? So here's a diagram of how the dynamic microphone works, the principle. The sound waves hits the diaphragm, and then you will be able to see the coil, the moving coil, which is connected. So when the sound waves hit it, it moves back and forth to a permanently fixed magnet. So electromagnetic induction is that principle, right? When you move a coil, right, through a magnetic field, you create a current. So a ribbon microphone, right, is made up of a thin ribbon of a corrugated metal. So you know what corrugated means? So corrugated means like it's like a zigzag design, right? Like an accordion. Have you ever seen an accordion? The bellows, the diaphragm. Yeah. So it's usually corrugated. That's not really corrugated. That's more like wave shape. Okay. But corrugated is like zigzag kind of a pattern. So it's a very thin ribbon. So that ribbon is suspended in the magnetic field. It also, right, works on electromagnetic induction. Same principle, okay? So when it vibrates, the movement within the magnetic field generates the electric signal. So this is a very iconic look of what a ribbon microphone looks like. This, if I'm not mistaken, is an RCA. Yeah, it's an RCA ribbon microphone. On the other hand, carbon, right? Carbon microphones have a capsule filled with tiny carbon granules sandwiched between two metal plates. Now, I don't have the description on this, but if any of you are old enough to remember the old dial-up phones and all that, right? That was usually, right? That's usually a carbon microphone. So carbon microphone, the quality is not right, not very good lah. Sound quality is low, but they are more robust devices lah. Okay, compared to a condenser, which of course you do not want to drop, or you do not want to damage. Moving on very quickly. Then you have your piezo. So piezo microphones. They use the phenomenon of piezoelectricity. Again, this is another electrical phenomenon. So what it is, it's an ability of some materials to produce a voltage when it's subjected to pressure, right? So the pressure can be physical pressure, right? It can also be acoustic pressure in terms of sound waves, right? So it converts these vibrations, right, generated by the pressure into an electrical signal. So piezos are often used as contact microphones, right, to amplify sounds from acoustic musical instruments, right? So you have your saddle mounted pickups on acoustic guitars, acoustic instruments. Generally, these are piezos. It's mechanically connected to the strings under the saddle. So when you strum the guitar, the vibration goes to the saddle, the bridge, then the piezo pickup picks it up. Okay? So this is an example of a piezo, how it looks like. Of course, there are many other designs. The piezo strips, some of them are straight, one strip like that. So this is more of a contact microphone. You see the three different contacts, and then they place it wherever, right, in the instrument to pick up the sound. Okay, moving on very quickly. There are some other specific microphone applications. So including, all right, a lavalier, right, very common. Right, you see this on the broadcast when you're interviewing people. You have the wireless microphone, obviously, okay. You have a boundary microphone, and which I actually have a sample in there. Actually, I'll show you guys later. Here's an example of a boundary microphone. This is a Crown PZM. So boundary microphones, typically they are condensers, and they work on the boundary mic principle. Okay, so boundary mics are very, very useful when you want the mic to be invisible. You don't want to put a mic up on a mic stand, because usually the video or the video director will think it's very ugly lah. Okay, or in situations where having something on a mic stand just is going to block the visuals. You see, so most common use boundary microphones in theater. So they're usually placed on stage, right, at the front of the stage or throughout wherever the actors are going to move, wherever they are going to move towards a different section, so that they can pick up the dialogue, all right, of the actor on stage clearly, right. Shotgun microphones, okay, you also will see this very often in production, in broadcast as well. Shotgun microphones, they capture a very, very narrow, they have a very, very narrow polar pattern of capture. And you have some instances parabolic, right? I don't see that often nowadays because shotgun mics are much better, have gotten a lot better already. But parabolic mics, you will sometimes find this in sports broadcasts, right? So you can see this guy is carrying a big parabolic dish, and then it focuses all the sound from what's great about this is that this can really pick up from long distance. So maybe when the football team is having a timeout, then they can pick up the conversation from the coach and everything, and then you can hear whatever they scold or whatever they're discussing their next move is. Maybe keep an eye out next time we watch a football or some kind of sporting event. Maybe can you spot some of them or not. All right, now with the many kinds of mics available today, it's not necessary, okay, not necessarily the wisest choice to always select the most expensive, the most accurate condenser microphone for every situation. Right, microphones, when you choose mics, you must be chosen for their particular application intended and the particular environment that is being used. Okay, so now the factors, right, of microphone choice are as follows. Number one, right, frequency response, right? So these are things one of the things that when you buy a microphone, when you look at a microphone specification sheet, look and study it. Number two, polar pattern. What's the pattern of the pickup of the mic? Then number three, the sensitivity. Okay, now let's go into frequency response first and foremost. So here, this is a frequency response chart of a unidentified mic. We don't know what microphone this is. But as you can see, this frequency response is kind of only flat around 700 to until about 2K, 2 kilohertz. Below 200 hertz, there's a significant roll-off in the lower frequencies. There's a bit of a dip at 400, and there's a boost, there's a peak, presence peak at about 6K, 6 kilohertz. Smaller one about 8K, and then after that it sharply drops off. Okay, right, so it's not a very smooth but it's just to demonstrate, to show you. So this shows you, right, looking at the frequency response can sort of tell you what are the characteristics of this microphone already. Okay, you will have that presence peak, it has a roll off at under 200. You pick the applications best for what this microphone frequency response is. All right, now let's go into polar pattern. Now, so this is again something that's very important to know. The various different polar patterns. So polar patterns are the different capture, how the microphone captures and listens to the sound. First one, omni. So omni is short for omnidirectional. So omnidirectional here means that it will capture the sound equally from all directions, 360 degrees. One thing about us as humans, we always observe and look at these things as 2D, right? But remember, sound is 3-dimensional. So when we say 360 degrees, we're talking literally 360 degrees in all directions, in all spheres. Okay, not only in the vertical but also in the horizontal. Cardioid. Okay, so this is probably the most common. I think 80-90% of microphones out there are all of the cardioid polar pattern. So cardioid comes from the word heart, and as you can see, it's a heart shape, right? Pickup pattern. So it picks up the sound best, usually generally from the front, and it has the most maximum rejection at 180 degrees to the rear. Okay, not going to spend so much time on this. Is a bit more technical stuff, which you can always read up and study on your own. Next one, you have a relative called the hypercardioid and supercardioid. Both of them, the hyper and supercardioid, have much narrower pickup patterns, so it's a lot more focused in the front, but the compromise is they have a little bit of pickup from the rear. Especially when you're using for live sound, it's very important to recognize, are you using a hypercardioid mic or are you using a cardioid pattern microphone, because that also determines how you angle the mic to, let's say, have maximum feedback rejection from, let's say, stage monitors. You have a cardioid microphone, you want to position it so that the back faces the monitor, then you get the best and maximum rejection. But if you have a hypercardioid, you want to angle it so that it's roughly 130 degrees off, right, towards the monitor. So you want to angle it slightly differently. So be aware of the polar pattern, and also you can also take advantage of that when you talk about recording lah. Now, the next polar pattern would be called the bidirectional or figure of 8. As the name implies, figure of 8, right, is shaped to be able to pick sounds equally from the front and the back, but have very good rejection, right, from the sides. Then lastly, okay, you have in the case of the shotgun mic, the directional, all right, polar pattern. So shotgun mics, they work using their design so that, through the design of their baffles, which if you saw earlier, you see these little lines across the barrel of the shotgun. So all of these, right, the sound that's entering from the side of the shotgun are all going to, because through all the different baffles, they cancel each other out. So that's why you get very good direction from only one narrow focus point and not from the side. See, so that's why they use this in broadcast and location sound to capture, right, dialogue, to capture, ambience and all that lah. Sensitivity. So this is the third one. We want a microphone that has high sensitivity or low sensitivity. So high sensitivity, low sensitivity. In this case, we're talking about what kind of sound source you're picking. Is it going to be a very loud sound source? Now, if you have a microphone which is which you're going to use to record with a very loud sound source, you might want to use something with a lower sensitivity, because if you have a high sensitive mic, it's going to output, a very, very hot output. You might distort the internal circuitry, you might distort the microphone, or you might distort, the preamp along the way down. So pick it based on what applications you want to use. Another characteristic is not one of the 3 factors, but it's something you need to be aware of. This is what we call the term called proximity effect. What it is a bass boost as the microphone is moved closer to a sound source. Very often you hear this, all right, with vocal mics, right? So with an announcer or someone voiceover, when you notice you put the mic closer, this voice, and here I'm just acting it and simulating it, okay? The voice will become, hey, 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 it becomes bassier, all right? When you put a mic closer to your mouth and you speak or you sing through it, it gets bassier. When you pull it off, even just like 1 cm, right, suddenly the bass response changes. Then when you pull it further back, it gets a little bit thinner, the bass response drops off dramatically. So this is something that you need to be aware of, something that you can always take advantage when you are recording. Now, proximity effect only affects directional, that means only cardioid, directional polar patterns. An omni microphone is immune, does not have a proximity effect, okay? Just be aware of that. Right, so here, proximity effect, very quickly. I can't remember this is for what mic, but this was taken from a typical, like a vocal mic, right? You can see presence peak, and then after that, after 10K, it rolls off already. So the top line, you can see it's 3 millimeters away from the sound source. So 3 mm in this case, literally, it means the microphone is touching the mouth, right? So at 3 mm, you can see the bass boost at like between 100 to 200 is more than 10 dB, man. You're looking at about 14 dB of bass boost. So that's a lot of bass boost, right? So when you back it off slightly, 25 millimeters, 1 inch, you're looking at 10 dB of bass boost, right, on this particular mic. Then pull it a little bit further. If it's 2 inches away, you get about 6 dB, right, of bass boost. And then when it's like distant, 2 feet away, like this, all right, then it's a little bit more flat and it rolls off, okay? So be aware, this is what proximity effect is. It's very easy to hear. Next time you go and take a vocal mic or something like that, you try it, you'll hear what proximity effect is. Right, so that takes us to the end of this module, right, microphone basics. What we're going to do next is we're going to take a look at the microphones that we're going to be using in today's session, right, today's drum recording session. There's going to be a combination of condensers, there's going to be a combination of dynamics, and also some ribbon microphones, and also I also got a very, very special mic as well, all right? So let's move on, and we'll see you in the next segment.